After successfully producing the video for the data question done in 2001, we now look at another video. Remember the video on data of 2001, the question was just raw data. But here we have the data and you are going to draw a graph representing that data, so that after that is when you are going to answer the questions after you draw the graph. So we are lucky in this video because we will also learn how to draw a graph, and finally we are going to also see how that data can be used to improve the human race. So, continuation of my data questions. Welcome. 2002 Biology Paper 1. Introduction. The data question serves to make concepts learned in theory clear, motivate further thinking, and make biology relevant in day-to-day living experiences. This video is designed to develop the ability to be guided, to do guided manipulations, paying attention to the importance of step-by-step approach, understanding the procedure, examining the data, and making the correct observations. For this one, you are going to plot the data carefully, choosing the correct scale, drawing smooth curves with free hands, and making the right decisions to answer the questions using information given in the data and the graph. So in 2001, our part was to examine the data. So I was saying in 2001 data question 16, because this question always was question 16, we examined the data and made the correct observations from the data. But here we are going further to plot the data after carefully choosing the correct scale, and then it is from this data we will make the decisions to answer questions using the information in the data and the graph. So this is like an improvement of the previous video. So this video will not be of any help if the questions are not done and the work is treated through theory approach. You develop analytic skills by practicing them. This is the only way you become aware of your strengths and weaknesses in biology. So, Biology Paper 1, 2002, question 18, 20 marks. Okay, this was question 18, 20 marks. Two persons, X and Y, drank volumes of concentrated solution of glucose. The amount of glucose in their blood was determined at intervals. The results are shown in the table below. So you can see time in minutes. The intervals are 15, 0, 15, 30, 45, 60, 90, 120, 150. And then glucose levels in blood per mil of 1,000 cubic centimeters. You see, we had X 0 minutes 87, Y 84. After 15 minutes, X was 112, Y was 123. After 30 minutes, X was 139, Y was 123. After 139, y was 170. After 45 minutes, x was 116, y was 188. After 60 minutes, x 100, y was 208. 90 minutes, x was 95, y 202. 120 minutes, 92 for x, 144 for y. And finally, at the end of 150 minutes, when the experiment was stopped, x was 88 and y was 143. So on the graph, on the grid provided, plotting graphs of glucose level in blood against the time on the same axis. You are being given 7 marks. We will show you how those marks are being scored. What was the concentration of glucose in the blood X and Y at the 20th minute? 2 marks. Suggest why the glucose level in person X stopped rising after 30 minutes while it continued rising in person Y. 2 marks. Account for the decrease in glucose level in person X after 30 minutes and person Y after 60 minutes. 3 marks. Name the compound that stores energy released during oxidation of glucose. And finally, the other question will be explain what happens to excess amino acid in the body. So these last 2 questions are theoretical from the knowledge you have learned of glucose or the digestive system. Plotting of the graph. Steps for plotting the graph. Analyze the data. Carefully read the table provided, noting the glucose levels from both person X and person Y at various time intervals. Step 2. Set up the axis. X-axis. Label this as time in minutes and determine an appropriate scale based on the time intervals given, e.g. 0, 15, 30, 150 minutes. Nikanya mweno nikunde tinda unibiwe. Sorry, the video, the camera went off. So set up the axis, and I've explained there. Y-axis, label this as glucose level, milligrams per dl, and choose a scale that fits the range of glucose levels provided for both individuals. All right. Steps for plotting the graph continues. Point 3. Plot the points. Start with the person X, plotting each time interval against the corresponding glucose level. Place a small dot or cross at each point. Repeat the process for person Y using a different symbol or color to distinguish between the two. Okay, for biologists, you can place a smaller dot, but for mathematics, we place the cross at each point. It is not recommended in mathematical graphs to put dots, but for biology, it's okay. But for mathematicians, you have to put the cross because you are sure that is where the point is. Dots can mislead you. Repeat the process for person Y using different symbol or color to distinguish between the two. Draw the curves. Connect the points for person X with a smooth curve. Similarly, connect the points for person Y with another smooth curve. Of the opinion that you have been taught by your teachers how to draw curves, especially in mathematics, when you are introduced to graphs, so that your curve will be as smooth as possible. Label the graph. Clearly label each curve with the respective person's name, X or Y. Include a title for the graph such as glucose level in brand versus time for persons X and Y. So you put that one as the title of the graph. Interpret the graph. Look for trends in the data such as the peak glucose level, the time it takes for glucose levels to peak, and how quickly levels decrease afterwards. Compare the curves to determine differences in how person X and Y metabolize glucose. So that is a graph of glucose level in brand against time. You can see the way I've labeled glucose level in brand against time, that's the title. Then on the x-axis, you have glucose level in brand milligrams per 1,000 cubic centimeters, and on the x-axis, you have time in minutes. All right. So the intervals are, after every centimeter, you have 10 for it to fit. Remember, you have to draw 2/3 of the graph or the grid. You are not supposed to draw a very small graph or a very big graph. It should fit the grid. And then on the y-axis, we are also having an interval of 10. Okay? And then you come up with a very nice graph where you start marking, and the P is protein. You see where the mark for protein was put in both graphs. All right. The curve, the smooth curve, see where we were putting the marks, and the labeling of the graph, identity of the curve. Y, X, you also get a mark. Each was getting half a mark. So for curve and identity, each curve was having half. So that now, for protein, you get 2 marks. Curve, you get 1 mark. And the other, identifying the curves, you get another mark. All right. You come now to the labeling of the axis. You get a mark. Okay? Axis. Labeling x-axis, also you get a mark. Scale with correct intervals, you get have a mark for x-axis and y-axis. So that one gives you a mark. And therefore the total mark will be, for the time, for the labeling of the axis, you get 2 marks. For the scale, you get a mark, that is 3. For the curve, you get a mark, that is 4. For the identity, you get a mark, that is 5. For the protein, you get a mark each, that is 7. And you get 7 marks. So graphs are very good marks earners. So marking of the graph, I have explained there. Axis, 2 marks. Scale, 1 mark. Protein, 2 marks. Curve, 1 mark. Identity, 1 mark. If protein is wrong, deny mark for protein and curve. Reversed graph, axis interchange, award maximum 3. That is 2 points, 2 marks. Identity, 1 mark. If graphs are separate, mark both of them and account for the one with the most points. Cancel the other if you have 2 graphs. Because some candidates, I don't know why they draw 2 graphs. You are supposed to draw 1 graph. The 2 curves must be in 1 graph. Answers to part B and C. What was the concentration of glucose in the blood, X and Y, at the 20th minute? For X, it was 120 plus or minus 3 milligrams per 100 cubic centimeters. So you find now 120 plus or minus 3 means it can be 123 or 117. Yes, excuse me, guys. So there was a correction I was doing there because, guys, I told you I'm typing. I'm the one who types these things. So X, 120 plus or minus 3, I've explained plus or minus 3 means milligrams per 1,000 cubic centimeters. Here there was an error here. We had omitted 10, but we have put it now. Y, 140 plus or minus 3 milligrams per 1,000 cubic centimeters means it can be 143 or it can be 137 or 137, 138, 139, 140, 141, 142, 143. You see how generous they are. Suggest why the glucose level in person X stopped rising after 30 minutes, while it continued rising in person Y. Person X is capable of regulating glucose, while person Y is likely to be diabetic, not capable, that is not capable of regulating glucose. Account for the decrease in glucose level in person X after 30 minutes and person Y after 60 minutes. X. Insulin released by islets of Langerhans in the pancreas. Excess glucose converted to glycogen in the liver. Y. Insulin is not released, thus the decline is due to glucose being released in urine. Name the compound that stores energy released during oxidation of glucose. This is known as adenosine triphosphate, but you can accept ATP. Explain what happens to excess amino acids in the body. They are deaminated, resulting in formation of ammonia. Ammonia combines with carbon dioxide to form urea and water. Urea and water makes what we call urine. Urea is passed out through as urine because of the water. Carbohydrate group is oxidized and stored as glycogen. What we run in real life. This exercise helps us understand how glucose levels fluctuate after consuming a concentrated glucose solution, reflecting the body's ability to process sugar in real life. This knowledge is crucial for understanding diabetes. Monitoring glucose levels over time is key in managing diabetes, where the body's ability to regulate glucose is impaired. Glycemic index awareness. Different individuals may respond differently to the same amount of glucose, emphasizing the importance of personalized dietary choices, especially for those at risk of diabetes or other metabolic disorders. Overall, this graph plotting exercise not only tests your mathematical skills, but also deepens your understanding of important physiological processes related to blood sugar regulation. So guys, that comes to the end of that wonderful presentation. I hope you have enjoyed watching the video to the end, and very soon we are bringing the data question of 2003 theory, biology, data question. So goodbye, and gain from that knowledge, especially on the part where they're telling you what we learn in real life. We have also taught you how to construct graphs from given data. Bye-bye, guys, and see you in my next video. Well. This video could not have ended without me acknowledging that the content remains educational and informative without violating any guidelines or ethical standards. This work is truly a team effort. There are too many people who inspired me to come up with the production of this video, and I thank them with all my heart. I would also thank my family members for their support, engagement, and tolerance during my long hours of typing the PowerPoint. I'm also grateful to all my comrades making the 2001 KCSE. I'm also grateful to all my comrades marking the 2002 KCSE Paper 1 who in one way or the other participated in coming up with the final draft of marking scheme in this video during their modulation as senior examiners. Special thanks to ChatGPT, an AI language model developed by OpenAI for providing assistance with creating content for this video. Thank you very much, guys, but we have some changes. So we just want to make a small correction there that I'm also grateful to all my comrades marking the 2002 KCSE Paper 1. So there I talked about the 2001. And I think it's because I had just produced another video for 2001. Otherwise, guys, welcome to this series, and I'm sure I'll sharpen you in paper biology theory, which is paper 1, data questions, and they are not very far from paper 3, which is practical.